Now, I want to take a moment to introduce John and Kathy from MicroBlocks. MicroBlocks is a free Scratch-like blocks programming language for learning physical computing with educational microcontroller boards such as the Microbit, Adafruit Circuit Playground Express, and many others. Their goal is to make MicroBlocks the most intuitive and engaging tool for physical computing imaginable and to create a global community of learners and educators around it. We're so excited to have them kick off the MNCodes Educator Summit. Welcome, Kathy and John.
Thank you. Thank you. Let me get my share going. Okay, the keynote today is what is physical computing? I think of it as a secret trick to engage students in hands-on learning. And this typically brings CS, broader than just the CS classes. John, why don't you introduce yourself?
Hi, I'm John Maloney. I'm the lead developer for MicroBlocks. And we'll say, I guess you're going to have another slide with a little more detail, right, Kathy?
Yeah, and I lead global partnerships and outreach for MicroBlocks. So we work very closely together.
So I've got a bachelor's and master's in EE and CS from MIT, but more on the CS side, PhD in computer science from University of Washington. I've actually been working on educational programming languages for almost 30 years now. Started in Alan Kay's research group doing Squeak and eToys, which old timers might remember some of those. Then I worked on Scratch for 11 years, which probably many of you have heard of. And then I did something that you probably haven't heard of called GP Blocks as a research project, which didn't really get completed, but it morphed into MicroBlocks starting in 2017. And that's the project that I'm working on full time and totally passionate about right now.
And I grew up in Minnesota, so I have a family of teachers and educators. My parents were both teachers. My dad was a high school math teacher at Coon Rapids. My mom was first in elementary and then did technology coordination for the Anoka-Hennepin district. My brother was a high school math teacher in Bemidji, retired now as Bemidji State, sort of part-time. My niece is a high school math teacher in Blaine, and I have other cousins and relatives. So I grew up undergrad Golden Gopher in electrical engineering, came out to Stanford, met my husband, took tech jobs, and I'm still here. But that's why I'm sort of excited. I go back to Minnesota periodically, and I'd like to coordinate some truly hands-on workshops, because I think that's one of the differences in just plain CS and physical computing is physical computing doesn't even feel like CS sometimes. It's more an interaction of the real world. So our agenda is focused on brief intros from myself and John about why physical computing and what is MicroBlocks. But then we're going to use MicroBlocks and real hardware to show off live demonstrations to try to get you to see the engaging things it can do across all different subject matter. First, my point about why is I'm an experiential learner. I love to do the actual hands-on tinkering and exploring. And I feel like it's way more engaging and fun for students. When I do workshops, they think they're at recess, And when the theoretical is important, but if it's only theory and you have two trains going up against each other, classic problem, and where do they meet? That only goes so far. You can only get so much engagement as students, especially if they've never ridden a train. But if you let them build two trains and then, calculate it and then measure against your calculation, now it's like a game. Are we getting the numbers right? It makes it much more fun. Recently, we wanted to highlight an exploration where a couple of teachers engaged with a company called DataBot. And the DataBot actually runs MicroBlocks, and it's got very high sensitivity sensors. So the graph there, where John pulled the data from a DataBot recorded in a couple of zero-G gravity flights. These are the astronaut training flights. You can see Colleen, one of the teachers, holding the DataBot. And the red line is altitude, I believe it. No, yeah.
Acceleration. The red line is acceleration, and then blue is CO2, and green.
And the green was pressure.
But what's weird is, and unexpected is that the CO2 clearly correlates somehow with the up and downs of the zero G flight. So this is like real science. Like why is that? You know,
Yeah,
and you could speculate about different theories and then figure out an experiment that would test your theories.
right. And you or I were thinking, do the lungs expand and contract differently under these pressures? Does the cabin pressure as a whole make these changes? So you have to do more detailed measurements as a follow-up. So it's physical computing is just very valuable. A couple of things just to show how it brings fun. I showed off a lot of demos at Maker Faire last fall back here in the Bay Area, where I have a smart Christmas tree and I have videos online on YouTube that show how to do that. Try to get the word out as much as possible. On the left side is a screen where one of my colleagues, mentees in Morocco, has a first robotics league, and her teams of students have actually engaged in the Morocco earthquake refugees that live in tents, and they don't even have computers for programming. So they've made programming assignments using two microbits, where one is the controller where you build up some commands based on cards, and then the robot moves based on your commands and you see if it got the right outcome. And I focus both in the US and internationally because I think the opportunity to learn physical computing is very important. You can solve your own local problems. So I do underserved girls for a Society of Women Engineers camp every summer in Santa Clara University, where they come and stay in the dorms for a week. We've been running since 2017 camps for think about fifth graders to build these. This is what my smart Christmas tree is based on. These it's a microcontroller on the back and strips of NeoPixels, and we got college students to volunteer, and then we put them in a shell. College students volunteer to solder them all together, and the kids spend fall quarter programming them, and then they're on display outdoors on trees in San Jose's big park every year.
And
And then I'm
most of the
part of
kids in that program are English language learners, so they're normally sort of underserved with technology.
right. And then speaking of underserved, internationally, the Tech Women program was set up by the US Department of State to bring women from every year for about 5 weeks from 21 countries in Africa, the Middle East, and Central Asia. And I've been doing that program since 2018. Now I have connections all over the globe in these 21 countries and beyond. And last year I went on a delegation trip. We do outreach trips as well. I went on the delegation trip to Kazakhstan, got in some workshops in Uzbekistan and Kyrgyzstan. I taught about 10 workshops, both to the teachers. I just bring them in. They learn as the students learn. And then just last month in this year in March, early March, I was in Nigeria. Again, a program set up by the Tech Women Fellows in Nigeria. And I taught at 3 different schools. The picture shown here is on YouTube. I had about 50 public school girls and about 1 laptop per table. It was outdoors. The power kept dropping out, but it's fine. Batteries on laptops and things. And it's just superb to be able to see the intellect of students all over the world, but they have the same, they have the same intellect. They just don't have the opportunity to learn this unless we can get it out there. So that's one of the goals of MicroBlocks. Take it away, John.
Okay, can you stop sharing?
Oh, sure. Stop.
So as that last slide that Kathy showed demonstrates, we share a lot of the same goals as Code Savvy, which is to inspire a wide range of learners, especially those who do not initially see themselves as potential technologists. And we've gotten feedback from people saying that with MicroBlocks and with the microbit and physical computing, they get girls and they get people of color more engaged because they don't see it as like a techie thing that isn't for them. They see it as something that maybe is for them.
Hey, John, can you do that slideshow mode? Yeah, there
Yeah.
you go.
So I'm going to talk about what is MicroBlocks. So of course, the most important thing is to do physical computing with whatever tool, and the most important aspect of that is the teacher. But a good tool can make a difference, can make it a lot easier. And we think MicroBlocks does make it a lot easier, just as Scratch made it a lot easier to teach programming. And I'm going to mostly show this via live demos. But before I get to the live demos, I want to just wait one point about blocks coding. So with physical computing in the old days, you would typically use an Arduino. And on the left is an Arduino program to blink an LED, which was often like the first thing you would do with an Arduino. And it's 140 characters. That includes a lot of unusual characters like curly braces and parentheses and semicolons. And pretty much if you get any character in the wrong place or omit a character, it's not going to even compile. You'll get compile errors, super frustrating for beginners. A lot of people maybe just give up and think, okay, programming isn't for me. In contrast, in MicroBlocks, the same program that blinks an LED is just 6 blocks. You can't make a syntax error. And even if you get the blocks in the wrong order or you don't have quite the right blocks, it's going to do something. And then you can kind of gradually sort of tinker around with it or get a little bit of help and get it working. So you get to a successful um, uh, uh, program very quickly with MicroBlocks. And I think that sort of early success is part of the sort of the magic sauce that keeps people going. Okay, I'm going to stop sharing. Oh, I didn't want to stop sharing my screen. I just wanted to stop the slides. Sorry, back to sharing. Um, I'm going to stop slide mode and go right into MicroBlocks. I'm launching MicroBlocks, the pilot version, because it has some new features. Normally we have a stable version that we don't update very often because teachers like to have a stable version of project programs that they're using in class so they can plan their lessons and stuff. I'm going to turn on my microbit here. And one of the new features that is in the pilot release is the ability to connect wirelessly, there's no wires, to the microbit. So I'm connecting to it. And as soon as it connects, two things happen. First of all, a sort of a green circle appears behind the connect icon. And that shows that it actually is communicating. But also, since it now is communicating, it knows, oh, this is a microbit I'm connected to. So it loaded a couple of special libraries. So here's a block that says display. I just clicked on it, and as you can see, a smiley face appeared right away on the screen. So this is very Scratch-like. You get immediate results, and it's different from MakeCode, where you have to hit a download button to compile and download your code before you can see it run on the device. I don't even have to pull a block out of the palette. I can click Clear Display. I can plot and unplot a point, display a character, etc. So it goes very, very quickly. To make a program, all you have to do is drag out a block. And so this one would say, when the A button is pressed, make a smiley face. And maybe I'll say when the B button is pressed, I want to clear the display. So now I've got an interactive program. And as soon as I created this program, it's incrementally downloading it to the microbit. So I can try it out right away just by pressing these A and B buttons. So this is one of the first things we have people do, and it's so easy that they immediately go, wow, I've made an interactive program. Um, Another thing that you can do that is cool with a microbit has some sensors built in. So that's what this is about. So uh, one of the sensors is a tilt sensor. They call it an accelerometer. So we can tilt it one way or tilt it the other, and we're getting different numbers. But I get tired of clicking this, so I'm going to automate that process. I'll say I want to forever say the tilt value. And so this is like in Scratch, it shows a little talk bubble with the numbers in it. And you can see that it's sort of around 100 on this side and minus 100 on this side and close to 0 on this side. But there's an even more visual way to view this data. And I can use the graph block, and I can then open this little graph window. And now we see that we've got sort of around minus 100 on that side. And if I tilt it this way, it's positive 100. If I wiggle it back and forth, I'm kind of alternating, and I can shake it real fast to make it change. So that's really cool. And by the way, you may have noticed that like I didn't actually have to stop the program that was running the say. That still was running, and I just added these blocks. So that's another thing that's similar to Scratch, that you can change the code even while it's running, and you see the changes right away. Well, so this is physical computing. We've got a physical device. It's got buttons on it that do things. It's got an accelerometer. But sometimes you want to go beyond the built-in devices. So I have here a bracelet that I made that actually has a bunch of LEDs in it. These are RGB LEDs, and I'm going to go ahead and plug that into the microbit, and and then I'm going to load a project that activates it. So I'm going to
I
open.
like how your bracelets accessories have Minnesota Vikings colors there, John. Good
Ah,
job.
that is actually wasn't planned, but I'm glad that that just happened to be the case. So it's yellow and purple is the Viking colors.
Yeah,
Okay, so
yeah, golden.
Okay, so I've loaded this new project and it has I just created in advance just to load a couple of extra libraries. So this NeoPixel library has blocks like set all the NeoPixels, and it's a little hard to see the colors through the camera, but these are all green now. So now I have a bracelet that's all green, and I maybe could change the program a little bit. I could say, oh well, let's make it be a random color. So there we've got like sort of a purple and another purple. There's a sort of a yellow color. And again, we can quickly turn this into an actual program. Oh, actually, I did that already. Um, so here's an actual program that alternates those colors. So I've got this kind of color changing thing. Similarly, there's another kind of device we could plug in. So this is a little some so-called servo motor. This is a micro servo, and it can turn this little arm left and right. So I don't have anything attached to this, but it's very easy to just hot melt glue on like some piece of cardboard or something. And so you could make a character that had an arm that waved or um, something like that. So I'm going to plug this guy in. And oh, by the way, this little thing with the sort of ears. This is an extension board called a ring bit, and it has a battery pack, which is nice. And it also has several connectors for plugging in these things. It only costs $8, so it's a pretty inexpensive way to extend your microbit. So here, I'll close this. Here, I'll tell the servo to go to 90 degrees or minus 90, and hopefully you can see that that arm sort of swings back and forth. And so just as with this, with the, ah, come on. Just as with the NeoPixels, I can make a little program that runs this. So now that I've got these two programs, I've got one that's running the NeoPixels and oh, you can't see that, and one that's running um, the servo, and they're running in parallel, which is pretty neat. That's a very natural way for kids. This is another thing that's like Scratch that there's a very lightweight, simple concurrency, and people find it very natural for the computer to be able to multitask since people can multitask. Um, so the last thing I wanted to show about this is that I can turn this off, and that of course disconnects it from the programming environment. But when I turn it on again, the program was stored in the flash memory. So it just starts right up and starts running again. So if you built this into, say, a Halloween costume, all you'd have to do would be to turn on the power, and you'd have like your flashing lights and your moving a servo motor. Uh, 26. Okay, yeah, I still have time to do one more demo. So I wanted to show as my last demo how you can combine um, MicroBlocks with the Teachable Machine to show AI things. So if you haven't seen it before, Teachable Machine is a project from Google that allows you to train an AI model, and it has several different kinds of AI models. Audio, there's one that recognizes the pose of your body. The one I've used the most is the image model, which allows you to train a teachable machine model to recognize different images. So I actually created one, um, and actually I'll switch to, so I created one and I'm calling it Stop Go. And when I run this model, so I'm running this in my own little sort of teachable remote control web page. But if you look down at the bottom, you see it has three different labeled numbers: nothing, stop, and go. If I hold up my hand like a policeman, stop is 1.0. It means like it's pretty sure that that's a stop gesture. If I hold up my hand like this with a thumb up, it says go is 1.0. And if I don't do anything, it's kind of confused. Sometimes it thinks it's go. I didn't train it very well. Um, but most of the time it's kind of split between all those different things. So to program microblocks to respond to this, I'm going to load a different program. And it's a really simple program. And when I load this, I haven't connect my board. When I connect the microbit, it will replace the NeoPixel program. Actually, I'm going to unplug just to avoid distraction, those things. And so the program is very simple. It says when I recognize the go gesture, display the check mark image, the yes image. When I see the stop gesture, it'll show the X, which is the no image. And if I'm not seeing anything, it will blank the display. So let's try this out. So I'll go here, I'll connect to my microbit, and it says it's connected. So let me try holding up stop. So that's the X. Let me try holding up thumbs up. That's a check. And some of the time it thinks just sitting here, it's a yes, but so it's getting some false positives. But again, that's part of the brilliance of training or using teachable machine. You actually learn that AI models are not perfect. With that, I'm going to turn it back over to Kathy and let her do some other demos.
All right, so I put on display a lot of hardware. Some people were chatting in the chat window about hardware. So John showed the ring bit. I actually have a ring bit attached to servo motors. So this is the ring bit car. So I can turn this on. Again, the battery pack is there. I have a couple of these, so we'll turn them both on. And then I have another microbit with a basic bit, which is even cheaper, but it has a battery pack built in. And then I strapped, oh no, it didn't have a battery pack built in. So I had to strap a regular battery pack, and I strapped some LEDs around it because it's more fun. So what John didn't explain to you is these microbits have a Bluetooth low energy radio. And so we have a very basic radio code library that we use where I can send it commands. I programmed the A command to go forward. And when I let up on the A button, it automatically sends a stop command. I use the B button to go back. And then I use a tilt sensor. If I tilt it to the left, it'll go left. And if I tilt it to the right, it goes right. So you need once you've programmed it, you need no computers. And this is kind of the idea with the Moroccan refugees, is they can program these things with no computer attached. Now, there's a new, again, only in the pilot, I'll set these aside. In the pilot version, we have something that interacts with Bluetooth beacons in a new project from MIT called Octo Studio. So if you've heard of Octo Studio, it looks like this. And Octo Studio allows you to have up to 5 shapes that you can beam to other phones. So we had one of our community members take that, reverse engineer those beams and enable them to be received directly from the microbit, which is not another phone, but it speaks the same wireless protocols. So I go and I say, when I touch this character of the robot, send the square, and then this is going to receive the square and take action. And it says, say stop, and it'll glow the robot. And then Octo Studio is, again, drag and drop blocks. And you can go into control mode, and I can go forward, and I can send a stop command. But I also, these robots, it's fun to see things move, but I also program the distance sensor so that something in front of it will also make it stop. So I could say go, let me see, stop. Sometimes one of the servos gets stuck. go and then stop, and then go back, stop, and then of course left and right. And whenever I put my hand in front, I'm going to stop. Now, John showed that you could also have a camera facing and have, this is for example, from DF Robot and a Husky lens. And we have libraries for this that you can attach to different microcontrollers and send commands to recognize different other shapes. And if I'd had time, I could have used the microphone of this car. So let me turn that off. How much time we have? Okay, we're approaching. And then I have one more program I'm going to show. One of the favorites when I go abroad is to show my Exco robot dog. And this is a little more expensive, but you know, all you need is one to really impress people. And so here I can do some just basic things with button inputs. I could have my voice trained to do it. I could have other IR receivers, but I'm gonna go ahead and use Octo Studio again and say, okay, stand up, crouch, down low. Here's the sit command. And then this one is going to do a handshake for you. Let's see, this one's going to search for food. And then this last one is one of the kids' favorites. And this neck, you can have it fetch balls. I've seen some autonomous things that people can do with this. So there's a lot of interactivity that you can learn from these types of toys. So I'm just going to switch back here. Let's see. Go back here, go to slideshow. So we unfortunately don't have all the time in the world, but we're going to have a slide that has our contact information. So John, you want to recap based on our demos?
Yeah, so in the demos, you saw that MicroBlocks is blocks code. It's live as you program. It can run autonomously, disconnected from the programming environment. It supports concurrency. As you saw with Kathy's wide array of boards, it runs on probably about 60 different boards at this point. It's very portable. I didn't demo this, but you can actually read your program back from the board if you accidentally deleted the source file. And we have a website with a bunch of great learning materials. Oh, and of course, the project is free and open source, and it's actually under the auspices of the
Software Freedom Conservancy.
Software Freedom Conservancy, which is a 501(c) nonprofit. None of us that work on MicroBlocks are paid. We're all doing this for passion. And yeah, if you want to learn more, go to the website microblocks.fun, or you can email us at interest@microblocks.fun, or you can email Kathy directly, or you can look at our Twitter feed at MicroBlocksFun.
Yeah, specifically reach to me if you want to gain discounts on hardware purchases, especially bulk hardware. If you want, training, I come to Minnesota periodically, and I love to train both teachers, students. Doesn't matter. Teachers learn while I teach students, or vice versa. So you can, reach out to me directly if you're interested in that. And we also, on the bottom of our website, let me just quickly jump there. At the bottom of our website, I also encourage you to engage with our community down here. Get in touch with click on the Discord server. So on Discord, we have a lot of interaction with people, developing low-level thing, and we'd like to see more teachers and even ambassadors. So if you want to become an ambassador for MicroBlocks and do more, let us know. Although we're a nonprofit, we can do a limited amount of funding to develop, nice curriculum in different subject areas. So let us know. We really want to see this take off. It's our goal to get equity in education. And we feel like physical computing is a great way to do that.